Quantum dots are actually used in a lot of different fields. But before I go into that, I want to ask people that watch this video to interact with this post, like it, share it, comment. And I'll just start with the one that I'm most familiar with, and that's for biomedical applications. They can be used as imaging probes for viewing different aspects of tissues, whether that's the enhanced permeability or attention effect of cancer cells and locating tumors, or specific targeting of different cells or tissues in the body. And this is just some examples of that. So these are looking at lymph nodes, or looking at tumors, uptaking quantum dots. Because of their really small size, they will very easily circulate inside the body. And because tumors have leaky vasculature, they can easily be kind of uptaken by tumor cells and tumor tissue, and they preferentially will kind of build up in those tissues. And then by taking a fluorescence image, you can then find those tumors. Another example that's probably really widely used is in televisions and LEDs. So quantum dots can be turned into the active layers of LEDs, and you can, by changing the different quantum dots in the active layers, change the color of the LED. So people have figured out how to make these into the LEDs and TVs. And so if you heard of a QLED TV, that is a TV that has quantum dots in the LEDs. And it really simplifies the design because you now only have to make kind of one emitting source, but by putting different colors in front of that emitting source, you can change the color really easily. And because the color is a function of size, just by changing the size of the nanomaterial, you can get different colors. And so you can get a lot more colors than your just standard RGB that you would typically see in your LED type devices. Another example is in the solar industry. Typically, your solar cells capture in the visible and the shortwave infrared spectrum, but the electromagnetic spectrum that's emitted from the sun emits, kind of very broadly. So there's wavelengths that contain energy that we can't, efficiently capture because the device materials that we use don't really absorb those wavelengths very well. But if you can, make a quantum dot that can absorb those wavelengths, then you can access the energy that's in those spectrums. So as you can see, there's a large percentage of the energy that we're just missing out on by not being able to collect all this. And making quantum dots that absorb in the infrared will allow you to capture some of that energy back. And I've made quantum dots that do that for a different purpose, but it kind of illustrates the point. So these are quantum dots that I made for mid-infrared emission, and you can see that they have this really kind of long absorption tail. So they're absorbing all the wavelengths of light that are below their band edge, and this inset shows where the band edge for these different quantum dots are. And I grew these, and when I did that, I could access different sizes or different absorbances by just letting the reaction, proceed, and the quantum dots grew larger over time. So by taking advantage of the photoelectric effect, you can take that incoming light and convert it back into an electron. And, the flowing electrons means energy. So you're now able to capture that energy that you were missing out before. And another example is in infrared detectors. So same reason, photoelectric effect. You can take a incoming photon, convert it into a voltage, and you can then turn that into a detector that can see infrared light. And this is just one example of some research of a group that's in Chicago that they're doing. And if you can imagine, this is going to be really lucrative because you're taking these really low-cost materials and turning them into these infrared optics, which, the defense industry is going to love this because you're making this really cheap solution process material and you can turn it into a really sensitive detector. There's probably more uses, but these are the ones that I found interesting. So yeah. But yeah, this has been the Mad Bioengineer. Be sure to like, share, and follow me if you don't already.